Hey guys, Mr. B here, and we are here for the virtual lab on lifting weights. I'm back with my lovely assistant Isaac. Say hi, Isaac. And we're going to be doing some weightlifting here because we want to see how much work does Isaac do when he has to do some weightlifting and how much power does he generate. So let's get started. All right, so we are here on the first machine, which is the lat pull down. And in order for us to determine how much work Isaac is going to do, we are going to need to measure the distance that he is going to be lifting these weights, as well as how much weight he's going to be lifting. So let's take a look, and we're going to have Isaac do one pull on this to get an idea of where those weights are going to go to, and then we'll go from there. All right, so the weight that Isaac is going to be pulling here is 60 pounds. Again, that is a force, but that is in pounds, and we need that number in newtons. So before we do any calculations, we're going to need to convert that 60 pounds into newtons. All right, so we are going to have our weight start here. Isaac is going to lift it up, and we're going to measure and see how far one rep for him is going to be. So Isaac, pull it up. So from the bottom to the bottom, we have about 73 centimeters. So every time Isaac pulls this weight, it's going to be 73 centimeters. We're going to record that on our sheet, and we're going to now see how many reps he can do in 15 seconds. All right, so Isaac's going to go in 15 seconds, and every time he pulls the weight down, that's one rep. So 3, 2, 1, go. 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right, that is time. So 9 reps is what he did. We're going to record that on our sheet and move on to the second machine. All right, so the next machine here that Isaac is going to be lifting some weights on is the shoulder press. Again, in order for us to know how much work he does, we need to know the total distance that he is going to be moving these weights. So he is going to push this up one time. We're going to measure this distance and see how far he's going to travel. So when you're ready, Isaac, let's do one rep just to see. Okay, so from bottom to bottom is about 21 centimeters. So every time he goes up, that's going to be 21 centimeters, and we're going to record that on our sheet. So you can put it down, and we'll go on to counting his reps. All right, so Isaac is going to be doing reps here for 15 seconds. So we're going to count every time he goes up, and we're going to record that on our sheet. So in 3, 2, 1, go. 1, 2, 3, 4, 5, 6, 7, 8, and time. So he did 8 reps in 15 seconds. Record that on your sheet and move on to machine number 3. All right, so we are now at machine number 3, which is the leg curls. What was the thing called? Leg curl. All right, I was right. Leg curl. So we're going to measure the distance that one rep for Isaac is before then we start counting his reps for 15 seconds. All right, so we're going to measure the distance that one rep for Isaac is. So Isaac, you want to pull it up? And it looks like we are at about 33 centimeters. So 33 centimeters is going to be one rep, and this is 60 pounds, just as it was for machine 1 and machine 2. All right, so Isaac now is going to do some reps for 15 seconds, and every time he puts his legs down, we're going to count that as one rep. Remember, that is going to be moving 33 centimeters. So in 3, 2, 1, go. 1, 2, 3, 4, 5, 6, and 7, and that's time. So 7 reps. Record that on your data table for machine number 3, and let's go on to machine number 4. All right, we're at machine number 4. This is going to be the bench press. So for this distance, we're going to basically measure the distance that Isaac is going to go from his chest up all the way up to full extension, and that will be the distance he's moving for one rep, and then we'll have him do for 15 seconds, and we'll count how many reps he does. This bar is 45 pounds, which remember, we're going to have to convert that into newtons. So Isaac, let's go ahead and bring it down to your chest. Have it go all the way down, and have you go up. So one rep is 50 centimeters. All right, so 50 centimeters. All right, so Isaac is gonna go for 15 seconds, and every time he pushes it up, we're gonna be counting that as 1 rep. So Isaac, gonna bring it out, put it down to your chest, and 3, 2, 1, go. 2, 3, 4, 5, 6, 7, 8, and time. So 8 reps. We're going to write that down for machine number 4, and we'll move on to the last one, machine number 5. All right, so we're here now for the last and final exercise. Isaac's going to just be doing some basic curls, and we are going to measure basically the length of his forearm, and we're going to double it because he's going to go from down all the way up to here. So as long as we know this distance, that's half of it, and then double it, and that's the other half. So let's just get this quick measurement. And let's say it's about 30 centimeters. So it's going to be 30 centimeters and then times it by 2. So this whole distance he's going to be moving this dumbbell is going to be 60 centimeters. This is a 10-pound dumbbell, which means, again, we're going to have to convert this into newtons in order for us to do our work calculations afterwards. All right, so let's move on to having him do some reps here. All right, so Isaac is going to be doing reps for 15 seconds. And again, we're going to count every time he goes up. That's 1. So in 3, 2, 1, go. 1, 2, 3, 4, 5, 6, 7, 8, and time. So 8 reps. Record that for machine number 5, and we will move on to the post lab. All right, guys, welcome to the post lab now of this virtual lab on lifting weights. We're going to be taking a look at the data and the post lab questions here. So at the very top of this handout, there's this thing with the procedure where it asks which machine do you believe you can generate the most power with. If you're doing this virtually, you don't need to worry about answering this question because you didn't really do the lab yourself. You just simply watch Isaac do it. So don't worry about that question. Also, same thing with number 2. Why do you believe that machine will work the best? Same thing. Don't worry about it because you didn't actually do this lab. So, all right, taking a look at the data then. We did 5 different machines: lat pull down, shoulder press, leg curls, bench press, and bicep curls. First thing we had to do was calculate our force from pounds into newtons, and the conversion factor for that is 1 pound is 4.44 newtons. So all I did was I took our pounds and multiplied by 4.44 to get these numbers into newtons. So if you didn't do these calculations, you should do them. Otherwise, you can just simply record down the numbers I have on your sheet. Next thing we also had to do was to take the distance for 1 rep and convert that into meters. We were, of course, measuring this in centimeters in the video, but we need these in meters in order for us to do our calculations later. So all we have to do is take our centimeters and divide it by 100. So for the lat pull down, we have 0.73 meters. For the shoulder press, 0.21 meters. Leg curl, 0.33 meters. Bench press, 0.50 meters. And bicep curls, 0.60 meters. And then, of course, we should have our reps done in 15 seconds, which, again, was from the video, and should have those recorded. All right, so from here, then, our first calculation we need to do is the total distance that Isaac moved these weights over 15 seconds in meters. Okay, so we have, of course, here, this is 1 rep, but he did 9 reps total. So what I'd like you to do is I'd like you to pause the video. I'd like you to try calculating the total distance that he did for all of these. Then you can hit resume, and I'll show you what I have for my numbers. All right, so these are the numbers that I have. For the lat pull down, total distance he moved, the weight was 6.57 meters. All I did was I took 0.73 times 9 reps to get 6.57. Shoulder press was 1.68 meters. Again, I took 0.21 meters, multiplied that by 8, and there we go. So hopefully all of these numbers that I have are the same as the ones that you have. But if you didn't get these right, you can simply fill in the information then based on what I have here. So, all right, next calculation we're going to do is how much work did Isaac do to lift all these weights? Now our equation for work is force times distance. So we're going to take our force for the lat pull down, which is 266.4 newtons. we're going to multiply that by the total distance that he moved the weight. Okay, so again, we have the weight or the distance here for 1 rep. We don't want to use that distance. We want to use the total distance he did over 15 seconds. So we're going to take our force applied, multiply by our total distance to get our work done, and that will then be in joules. So again, I'd like you to pause the video. I'd like you to calculate the amount of work that Isaac did on all 5 of these machines. Then you can hit resume, and I'll show you the numbers that I have for my calculations. All right, so for our lat pull down, I had 1,750.2 joules. Again, I took 266.4 newtons and I multiplied it by 6.57 meters, and that's how I got this number. So same thing for all these other ones. I took the force multiplied by total distance, and there we go. Okay, so hopefully your numbers match up with mine. If they're a little bit different just because of how you rounded, don't worry about it. You know, as long as the numbers are close to mine, it's completely fine. All right, last thing that we need to calculate is the power that Isaac generated. And our equation for power is work divided by time. So we have the work done for each of these now here in this column. And the total time that he moved all of these weights was 15 seconds. So we should be able to calculate our power pretty easily. But I'd like you to pause the video, do that math out for all 5 of these, and then you can hit resume, and I'll show you what I got. All right, so here are the numbers that I have for my power. Again, the units for this are going to be in watts. And all I did for this first one was I took the amount of work that Isaac did and I divided it by 15 seconds. And that is how I got 116.7 watts. And then again, the same thing for the next one, 447.6 joules divided by 15 seconds. I get 29.8 watts. And so on and so on. So I hope again that your numbers match up with mine. If you did your rounding a little bit differently than mine, that's completely fine. As long as they're not drastically different, you probably didn't make any mistakes. All right, so then let's move on to our post-lab questions here that don't involve calculations. So number 3, it says, which machine allowed you to generate the most power? Or in this case, which machine allowed Isaac to generate the most power? So if we take a look at our numbers up here, it looks like the lat pull down was the one that he generated the most power with. So we can just simply put that in here. So you can say the machine that Isaac generated the most power with was the lat pull down. And number 4, why do you think that machine worked the best? And what factors determined your power on that machine? So again, in this case, why do you think that machine worked the best? And what factors do you think determined Isaac's power on that machine? So, you know, you can kind of put down probably whatever answer you want, but I would just say, like, you know, maybe Isaac has really strong shoulder muscles, and that factor allowed him to generate the most amount of power because he was able to do the most number of reps. So I'm just going to say I'll just say, like, Isaac has really strong shoulder muscles, and this machine allowed him to do the most amount of reps as well as use the most amount of weight compared to the other machines. Okay, so remember that the factors that determine your power is your work and your time. Now, in this lab, the time that Isaac did for all of these was the same, so that didn't change. The only thing that really changed between all these was just his work. And the lat pull down, he definitely generated the most, or he did the most amount of work with the lat pull down, primarily because he did the most number of reps, and he also had a very high weight for that, or high force for that, which again allowed him to generate the most amount of power. So. All right, number 5, was there any error involved in your data, and what would have caused this? Okay, so in terms of error, there's probably always going to be error when you're making measurements, but if we have any error for this lab, the things that I would consider that could potentially be wrong is the amount of force being applied. Now, we did have 60 pounds for some of these machines, but they were cable machines. And I don't know how much you know about cable machines, but cable machines, typically the cable goes through a pulley system. It's not like you're picking up the weight and you're like lifting it yourself, right? It goes through a pulley system. And the pulley system, depending on how the pulleys are set up, can reduce the amount of weight a little bit, or also could increase it because the cord, the cable, has to rub against something as you pull it, which essentially is adding more force because you have now friction you have to overcome when you pull on things. So there certainly could be some error with our force numbers here because our force could be maybe a little bit too large or a little bit too small, depending on how the machines worked. In terms of the distance that the object moved as well. I mean, we only measured 1 rep. So for all these, Isaac pulled down on the machine 1 time, or he essentially did one thing and we measured that distance. But every single rep that Isaac did on all these machines probably wasn't the exact same distance every time. It was probably just kind of close or an approximate. So the total distance that he moved these weights is probably not super accurate. There's, definitely some wiggle room there because each rep he did probably was a little bit different. So that also is going to be some error, and that would have our numbers be off a little bit. So, all these factors essentially would have error on our data. So we're going to say this something along the lines of, yes, there definitely was error in our data. Error could be caused from the machines and not accurately being able to determine how much weight Isaac was lifting. Also, human error played a role because we only measured the distance that Isaac moved the weight 1 time, and then we made the assumption that every rep Isaac did, he moved the weight the same distance. In reality, there were probably some reps where he moved the weight further or less far, which would mean that our total distance is not accurate. Okay, so those would be the things, like I said, that I would consider error to be, or where error could have been caused. But for this lab, it's fine. So, all right, last question. If you were to do this activity again, what would you change or try differently? Okay, so this one you can kind of answer on your own in a lot of different ways. So if I were to do this lab differently, most likely what I would do is I'd actually have a third person, and I would probably have a meter stick set up like right next to the weights. So every time Isaac did a rep or whoever was pulling on the weights, we could actually measure that distance for every single rep, so that we weren't just, saying, oh, here's the one, and then just everyone after that's going to be the same. So we could actually have accurate numbers for all those. The second thing I actually would probably do as well would be take a spring scale and hook it onto like the handles of the machine, or use some kind of measuring device to measure force. So like with a lat pull down, when you pull down on the bar, you could take a spring scale and pull down on the bar and actually see like how much force does it actually take to pull this thing. There might be 60 pounds, like on the machine, but if you pull it and it's really only like 50 pounds, or maybe it's like 70 pounds because you have to overcome some friction, it would be nice to know that rather than just assuming that it's 60 pounds. So those would be the things that I would do differently. But again, you can answer this whatever way you'd like. So I'm going to say that. To say, if I were to do this activity again, I would have someone be measuring the distance that the weights moved for every rep on each machine. I would also use some kind of device or tool that could measure how much weight was actually being used for each machine, rather than trusting the machine to tell me. So, all right. Anyway, So those are all the questions for the lab. I hope that makes sense, and I hope that you learned a little bit more about work and power and how to calculate the two things. Yeah, or you did this lab in person and you had fun. So, all right, guys, that is it for this one. I am Mr. B. Thanks for watching. And if you have any questions, as always, make sure you reach out. All right, I will see you in the next one. Bye.